In this example problem, we are going to make a regression model which predicts the selling price of a house based upon 4 predictor variables: the size of the house, the number of beds the house has, the number of baths the house has, and whether the house is a colonial or not. But we want to make sure that that is an accurate way to do things. So we are going to test for the joint significance. And what that means is that using all 4 of those predictor variables in combination will have an influence on the price the house sells for in a way that not using all 4 of them would not. Like, we would definitively come up with a different number for price using all 4 than we would if we use, say, just house size and number of baths. So all 4 of them jointly will give you a different return than any combination of them that's not all 4 would. So for your null hypothesis, it is that your slope for all of these are not equal to 0. Each one has a slope which in some way, if you put it into your model, will affect the return that you get at the end. And your HI in this case is that 1 is going to be different from 0. So basically in your null hypothesis, what you are stating in this case is that they're not jointly significant because you would have gotten the same return from any one of these variables because they're all equal, whereas your alternate hypothesis is stating that the way things are working, putting all of them in together, at least one of these things has to cause a difference in your output, in your Y, in your price. So what we have here is a data set of the last 36 houses that sold in the Finger Lakes region of New York. We are going to create a regression equation which estimates the price of this example home based upon its predictor inputs: the size of it, how many beds and baths it has, and in this case that it's not a colonial. And once we have that, we're going to make sure the model's good by testing for joint significance. And then also we're going to test for the individual significance of all of the inputs. So instead of all 4 of them together, is there really an influence on the thing? If we only use one of these, would it be significant to determining the price if that was the only predictor variable we used in the model? So let's start firstly with everything involved. And I'm still doing a regression equation, so I got to use the data analysis tool pack one more time under the data tab. And I'm going to go to regression. And what I want right here is what is Y and what is X? Well, Y is our output. X makes Y change. And the thing that we're saying right here is all of these different predictor variables dictate what the selling price of a house is. So my Y range is going to be everything inside of column B. Our predictor variables are everything in C, D, E, and F, the 4 different variables that we have to help us predict the selling price of this house. And it's already in my X range over here. It'd be C1 to F37. Everything checks out. That's where I want to be. I have the labels listed in here because I used row 1. And for an output range, I want to put this in a spot that's immediately underneath the table that I'm working with. So I'll go with cell H43. And when I hit OK, I should get my regression return, my summary output. And I did. There's all of our information. We have our goodness of fit up here from our R square, etc. We have our ends and some information that we're going to use later about our significance. And then down here, what I'm really looking for right now for the regression equation is this. What we're saying is that a house that theoretically was 0 square feet with 0 beds, 0 baths, and was not a colonial, it would sell for $165,000. Again, that's not a realistic thing that could happen in the real world because you can't have a 0-foot house with no rooms in it. But just hypothetically, that's what it would. And then for every additional unit of a predictor input, it increases the selling price by that amount. So every square foot a house increases the selling price by $92-ish. Every bedroom increases the selling price by about $4,300. Every bathroom, crazily enough, increases the selling price according to this information we have by about $66,000. And people in the Finger Lakes, I guess, strongly prefer colonials because if the house is built in the colonial style, it increases its price by almost $75,000. So step 1 that I have to do is estimate the price of this example home based upon those coefficients for each of our predictor variables. And I'm just going to fill in the equation over here. B of 0 is just our intercept, the 165,088. And I'm going to add to that the slope of our first coefficient for our predictor variable, which is this 91.68, if you will. for each square foot of the house times the size of the house that we're predicting for, which up here is 2,200. And I'm going to close that parenthesis. And I'm just going to repeat the process for the second, third, and fourth predictor variable. I'm always going to add in the product of the slope for that predictor variable, times what amount of that predictor variable our example home has. So for the number of beds, it would be the slope for the number of beds times the 3 beds that this place has. Add to that the product of the coefficient for the number of baths, that crazy 66,000, times the 1.5 baths that this place has. And then lastly, I'm going to add in the product of the coefficient that we have for whether it's a colonial or not, times the fact that this place is not a colonial. And when I throw that all in there, I come up with an estimated price of $480,620.66. So based upon the inputs that we have here, this home that we have the examples for in the Finger Lakes, if sold today, would sell for $480,620.66. Is that a good prediction? We used 4 different predictor variables. We want to know at the 5% level if there is joint significance amongst all of these variables. And our test significance level is 0.05. If I can get in the right spot, there we go. What is the p-value for joint significance? Well, actually, the summary output gives it to you, and it's right over here, the significance of f. F is used for a distribution where you have a ton of different variables in. F is the probability that there is significance. In this case, we have an infinite small number for our p-value for significance. That looks like it says 1.03, but this e to the -9 over here means it's in scientific notation. We'd have to move that decimal space 9 spots to the left. So our number is actually, if you want to look at it in decimal form, point, then 8 zeros, then 1, or like 1/100 millionth of a percent chance that we're going to say that these are jointly significant when in fact they're not. So is there joint significance? Absolutely. The chance that we are using a variable in here that is not going to have an effect on the selling price of a house is near 0. Okay, that makes things look good. At least we're happy that we have that all in there. Let's go through and follow this up. We'd like to know if all of the variables are individually significant. Well, we have that information in our summary output too. So I'm going to go to the spot where I need to put x1's p-value in, hit equals, and I'm going to scroll down and find it, because that information is all provided right here in this row. The p-value for house size in square feet is 0.008. For number of beds, it's 0.8153. For the number of baths, it's 0.0111, if you want to round off. And for colonial or not, it's 0.0105. So if we go through and we say, in this case for the house size in square feet, that's a significant variable that will end up influencing our y, the price this house can sell for. If we go through and say it's significant in our testing, and then once we get all of the results for every house that's sold in the Finger Lakes, we find that it's not significant in determining the selling price of a house, the chance of that is so incredibly small. It is way, way less than the 5% level we're allowing ourselves. So is x1 significant? It absolutely is. Is p less than alpha? Yep, that p right there is less than this number. And I can just go through and bring 1, 2, 3 values down for our x of 2, x of 3, and x of 4. The 4 different things that we are using in our test. So I'm going to bring those numbers in there. And now I can compare each of these individual inputs to our test level, 0.05. Well, based upon the information we have, saying that x of 3, I'm going to skip x of 2 right now, is significant and being wrong, the chance of that is only a little over 1%. That is way less than the 0.05% chance we're allowing ourselves, so that's a yes. x4, same thing, that's about 1%, less than the 0.05, that's significant. But what's not significant is that guy. We are saying with that p-value right here, that based upon the information we have, if we use the number of, what's x2 again? X2 is the number of beds. If we use just the number of beds to predict the selling price of a house, there wouldn't be significance. We wouldn't have a return that really gives us any meaning. So is that significant? No. And now we're asked to make a revised estimate on this price, throwing out the variable that wasn't significant. So now this guy's got to go. The number of beds is not individually significant. And when you use regression analysis for the data analysis tool pack, you kind of want to have all of your numbers in one place so you can highlight all of them. So what I want to do right now, since I don't want number of beds, is to move it out of my way so I can click everything else at once. So I'm going to click D to highlight the whole column. I'm going to go over in the middle of row 1 until I get that particular cursor, the black cross if you will. Hold down Shift, and I'm going to drag that guy over until he's all the way at the end. And now I can go back to my data analysis tool pack, grab the regression equation or the regression thing one more time, and change my inputs for the way that I need. For our Y range, I still want it to be all the prices, so that's good. For my X range, right now I have everything in columns C through F. Well, we're just saying the beds, which is now in column F, is not individually significant. We don't want it, so let's clear that out, and instead just grab all the returns we had for the 3 variables: house size, number of baths, and colonial or not, which we proved were individually significant. So I'm going to go and highlight everything in C1 to E37. Had the labels in there, so I'm going to keep that. For my output range, let me go and just throw this underneath the last one that I had down there. And oh, I didn't mean to do that. Sorry about that. I forgot to click out of the thing. Let me go grab it one more time. My bad. Going up, and I want everything that's in C through E for my X input, and then this time remembering to click on output range. I want to throw that underneath the last set of numbers that I had. And I'm going to hit OK. Something that I do personally when I have multiple summary outputs going based upon, I'm playing around with different variables that I want to throw into my equation, is I do something to make them look different. Now, whatever you want to do, you can like change the color behind all of them, but usually I go to the summary output and I just put something in there that changes what it is. So this time I'm going to say without beds, just so I can remember which one is which and I don't get confused about what numbers I'm grabbing. So now, if we throw out number of beds in calculations here, what is our revised price? Well, let's do the same thing we did from the very beginning. We are going to make a regression equation that is the intercept, which is now $174,000 and change after we threw out the number of beds as one of our predictor variables, times the coefficient for our first variable, which was individually significant, the house size, times what we have for this particular input, which is, this is a 2,200 square foot house. Add to that the product of the coefficient or the slope for our second predictor variable, which is the number of baths, times number of baths times the number of those that we have for this house, and that is the 1.5. And yeah, it's real easy to accidentally click the thing that you disregarded, so be mindful that you're actually clicking the predictor for your correct input in this case. And then one more time, we said that whether it was a colonial or not was individually significant, and it has a coefficient of a little over $74,000. Let's multiply that by this 0 because it's not a colonial. And when I do that, I come up with $482,791.38. So what does this all mean? Well, it means in this case that having them all in here will make a unique prediction for our selling price of the house, that $480,620.66. If we did them one by one individually, we would be able to make a reasonable prediction based just on the square foot of the house. We'd be able to make a reasonable prediction based just on the number of baths the house has, and we make a reasonable prediction on the price of a colonial versus a non-colonial. But what doesn't seem to be individually significant, at least based upon this sample, is the number of beds that a house has. So if we throw that out and we do it with the other 3 remaining variables that we have in here, it increases our estimation on the price of this house up to almost $483,000. Does that mean that this one's better? The answer to that is I don't know. This is not an exact science. We're kind of playing around with information right here. Don't always be tied to the numbers. These numbers only represent something, and I'm thinking about this in a more holistic, broad sense. Does the number of bedrooms that a house has influence how much it sells for? I'm going to say yes to a certain point. There's families out there that would much rather have a 3 or 4 bedroom house than a 2-bedroom house. So I feel like it does have influence, and the numbers are just a little skewed from the information that we have. That being said, I think there's also a cap on that. Like, going from that 2nd bedroom to that 3rd bedroom is a big jump if you've got 2 kids. If you're a house that has 5 bedrooms going to the 6th bedroom, isn't that big of a difference? And also, thinking about this as well, if you had a house that was 1,000 square feet that had 4 bedrooms in it, it would be a lot of really small bedrooms packed into one place, which might not sell for as much as a house that was twice the size with 3 bigger bedrooms. So I am personally not throwing out the X2 over here. I'm not going with the second guy because I feel like the number of beds should be quantified. And the real problem that we have here is, firstly, it's a relatively small sample size, but also we're doing linear regression, and I don't think these returns should be linear. For example, the number of baths. I grew up in a house with 1 bathroom with a family. It was miserable. I can't tell you how many times I had to wait to get in the bathroom when I didn't really want to. Having a 2nd bathroom in the house is awesome. That extra bath has, to borrow an economic term, so much marginal utility. Having a 3rd bathroom in the house wouldn't be nearly as important as having the 2nd one. And then if I had a 4th one, it would kind of be useless. I don't know why you would need 4 bathrooms unless you got like 12 people in the house. So I don't think this is linear. I don't think each additional bathroom increases the selling price of a house by the same amount. I think we have to go with some other form of regression, like you guys might be covering when Chapter 8 comes around.